Okay, geometry, ladies and gentlemen, let's begin with 12.2. So when we're talking about surface areas of different prisms, that's what we're looking at here. So we first want to consider what each net looks like. So remember that a net is just, if I unfold the shape, what will it look like? They all kind of have a little distinct value to them. So if I look at the triangular prism as a net, I end up with two triangles, represents the top and the bottom there. Then I have this big rectangle that represents the bottom. Then I've got two additional rectangles that look like that. So when I look for the surface area of this, I'm going to take area of a triangle, area of a triangle. The good news is these two should be the same. So if I figure out one, I figure out the other. They're not two different sizes or anything. And then I also want to figure out the area of three rectangles. Okay, but this side matches up to here. This side matches up to here, and likewise down below. And then you're just going to take the bottom times this side length here. A rectangular prism can confuse some kids because they're not always 100% sure kind of what's the base or kind of what a net might look like. So if I just consider looking at the bottom first, that's a rather large rectangle. Then next to it I have a short rectangle, short rectangle, short rectangle. So that's representing these three sides. Then I have the bottom. So I need a short rectangle, and then I need another long rectangle to represent the top. Okay, so then I have to figure out the area of four short rectangles and two big rectangles, and that would give me my surface area. My surface area basically boils down to figuring out what is the area of each of these little shapes and then putting them together. So kind of my big idea is going to be just area of the base times each side, or plus each side, sorry. So for a cube is actually pretty interesting because a cube has 6 sides, but all 6 sides are squares. So I've got 5, then I go one more 6. So all I got to do is figure out one of these and then multiply it by 6, which is kind of cool. So the shortcut, and I'll kind of show you where you get this. Actually, let's finish this first. So a pentagonal prism is this. So you start with a pentagon, and then you have another pentagon here, and then you're going to have 5 rectangles like that. Okay, so this side matches up here, this side matches up here, this side matches up here, this side matches up here. So when I fold it back together, that's what it's going to look like. So I would need the area of the 2 pentagons, and then the area of a rectangle times 5. And a hexagonal is going to be similar. You're just going to have one more side. So if you do a quick sketch of a hexagon, you're going to have one extra side because this is going to match up to the top. So what you're going to do is this. For each one of these, you've got a base. In fact, you've got 2 bases. Okay, so you've got one here, one here, one here, one here, one here, one here. If I call those 2 bases, and I can call those 2 bases. So what I want to figure out the surface area, and this is to figure out the surface area of everything, I want the area of the base times 2. And then what I do is I kind of do a shortcut. I do a perimeter of the base times the height. All right, so what's that do? A perimeter of the base times the height. That's supposed to be an h. And what that does is says I'm going to take this times my height, And that kind of shortens up figuring out the area of all my triangles into one step. Okay, so I got to figure out the area of the base, whatever that shape is. And then double it. Then I'm going to figure out the perimeter of the base, remember, which is the distance around times the height. Cubes are a little different, and with that cubes, I can just figure out the area of one square and multiply it by 6. That gets me my answer. So if I look, a base is going to be considered these or this or this. It's usually a non-rectangle shape. Usually. Every once in a while it might be. A lateral face would be considered one of these, okay? Just like a rectangle on the side. A lateral edge would be considered a line. A base edge would be considered a line on the base. And my altitude is my height, which would be like this, straight up and down, okay? For this oblique one here, it would be whatever distance it is from the bottom straight to the top. So that would be my height there. Last piece, pay attention to this. A cross section would be, what would it be if I cut across the middle? What shape would I see? And the big idea is that it would match the base. Okay, it's going to match the base. So my lateral area, which is different than surface area, lateral area is going to be just perimeter times the height. Okay, so if I look, I want A plus B plus C times the height, okay? Because to think about figuring out my area, it'd be C times H would give me that. B times H would give me that. And A times H would give me that. Those three together are going to give me my lateral area. Lateral area means no bases allowed. Okay, no bases allowed. It's going to be perimeter times height, so I don't even include the bases. So lateral area is just going to be perimeter of the base times the height. So once you decide what the base is, like here is your triangle, that's your base times the height. So when I look, what kind of prism is this? Well, it's a triangular prism. How many vertices? 1, 2, 3, 4, 5, 6. 6 points. How many faces does it have? It's going to have 5. How many lateral faces? Lateral means no base. So there's going to be 3. How many edges? Edges, you just count lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. A cross section should be a triangle. And my lateral area is going to be perimeter of the base times the height, but I'm missing a side. So to figure that out, I'm going to do Pythagorean theorem. So this length is going to be 7.81. So I add 5 and add 6, and I multiply by 7. 7.81 plus 5 plus 6, all that times 7, is going to be 131.67 centimeters squared. That's going to be my answer, okay? So here, this is a hexagonal prism. All right, so you can start filling that in. So this is going to be a hexagon prism. How many vertices does it have? How many corners? That's going to be 12. How many faces? There's going to be 8. How many lateral faces? 6. Lateral faces end up being all of your rectangles going around the shape. How many edges? Well, you got to count. 1, 2, 3, 4, 5, 6. 6 down here for 12. 1, 2, 3, 4, 5, 6 makes 18 edges. And a cross section perpendicular to the base is just going to be the same shape as the base, and it's going to be a hexagon. So lateral area, you want 5 times 6, 5, 5, 5, 5, 5, 5, or I can go 5 plus 5 6 times 12. So 30 times 12 is going to give you 360 centimeters squared. Now, how does that change when I go to surface area? I do that same thing. I do perimeter times the height, but then I add the area of the two bases. So here, if I figure out the surface area, I'll consider this square to be the base. So my perimeter is going to be 4 plus 6 plus 4 plus 6 times 9. Okay? So that's going to be 10, 20, so that's going to be 180. Plus twice the area of the base. The area of the base is just 6 times 4. So plus 48. So that answer is going to be 228 feet squared. For number 4, find the surface area of a triangular prism. I need to figure out that third side. So this third side is going to be 16.97 millimeters. So perimeter of the base times the height. And all I did, Pythagorean theorem. We've done that a lot. You guys should start to recognize that. So 16.97 plus 12 is going to be 40.97 times my height, which is 8. Now remember, this is kind of laid down, okay? This here is going to be my height. This here is going to be my base, rather. 8 is going to be my height. So I take that times 8, and just the lateral area is going to be 327.76. That's just my lateral area. Then I need to add the area of a triangle times 2. So I take 12 times 12 divided by 2, which is going to give me 72. Okay, so one of these is 72, then the other one is 72. So I'm going to add 144 to that answer. So my answer is going to be 471.76 millimeters squared. Last one. This is my base. So perimeter, 6 plus 6 plus 6 plus 6, or 24, times 12, which is going to be 288, plus twice the area of the base. So it's going to be 2 times 36, which is going to be 72. So my answer is going to be 360 centimeters squared. Sorry about that. So, how does that change for a cylinder? The answer is not a whole lot, except for a cylinder. All that changes is my area is going to absolutely be a circle. So my base is going to be a circle all the time. All right. So what's that look like? The area of a cylinder. Well, my lateral area is just going to be, if I think about this, my lateral area, my perimeter around the base is a circle. So how do I figure out the area, the distance around a circle? It ends up being the circumference. So I end up taking 2 pi r times my height. So this is kind of taking the place of the perimeter from the last part. Okay, so I'm going to take the 2 pi r times h. That's going to give me lateral area. Surface area is not much different. I'm going to take the area of the two bases, except I know that the area of the two bases is going to be a circle. So I do pi r squared times 2. All right, again, I know that this represents the perimeter, the distance around my circle. So here, diameter is 15. Okay, radius is going to be 7.5. So I take 2 pi r times my height. The height is going to be 18. So I take 15 times pi times 18. So my lateral area is going to be that. 270 pi millimeters squared. If I wanted to multiply it out and get big ugly decimal, I can leave it like that as well. So then for area of the base, that's going to be 7.5 squared times pi. And that's going to be times 2. So that's 353.429 pi. Then I'm going to add those two. Could I get a big ugly decimal? Absolutely I can. I can just also leave it as 623.43 pi millimeters squared. That would give me my answer. All right, so if I have a radius of 5, height of 9, remember, 2 pi r times height plus 2 pi r squared. Remember, that's your area of a circle. Remember, that's your circumference of a circle. So this would be 2 pi times 5 times 9 plus 2 pi 5 squared. So that's going to be 90 pi. That's going to be 50 pi. So my lateral area is going to be 90 pi inches squared. Surface area is going to be 140 pi inches squared. I can absolutely multiply that out if I want to. I don't need to, but I can. Couple more, just checking. Diameter is 6, height 4.8. So if the diameter is 6, that means the radius is 3. So I'm going to take 2 pi times 3 times my height of 4.8 plus 2 pi 3 squared. So if I take 2 times 3 times 4.8, so that's going to be 28.8 pi plus 18 pi is going to give me 46.8 pi centimeters squared. Now that's my surface area. My lateral area is just that. All right, no bases for that one. Okay, last one. What's the radius of the soup can? Well, you know that this is your circumference. So that's going to be 15.7. And you know that that's 2 pi r. So all I'm going to do is divide that by 2 pi. So a little division divided by 2. And that's going to give me a radius of 0.341 inches. Oops, hold on. Quick check. I made a hiccup there. How about 2.5 inches? That makes way more sense. Okay, so play around with that. Write these formulas down. You do have a formula sheet in Schoology. I encourage you, print it off, put it in your iPad. Make sure you're filling these in as you go because you can use those on upcoming quizzes and tests. If you have any questions, please feel free to contact me. I look forward to talking to you.